Okay, so the first thing I want you to do is to answer these two questions on your own, write something down, see what you get, pause this, write it down, try to answer these questions, and then come back, push play, and then we'll talk about these two questions. Excuse me. So on this first question, it says, what's the relationships among the measures of angles that you see? Okay. Now, based off what we talked about already in the last chapter, you could probably look at angle 1 and angle 2. Look at angle 1 and angle 2. Those would be linear pairs. Okay. Just like, okay. So let's go ahead and write this down. So angle 1 and angle 2 are linear pairs. Okay? Linear pairs, remember, are two things that add up to equal 180. They're supplementary. Okay? But if we take a look at it, notice that 2 and 3 are also a line that create a linear pair. Okay? So 2 and 3, linear pair. Okay, and you'll notice if you look at it too, you also have angle 3 and angle 4 also create a line, which is two angles that create a line, which is also a linear pair. And then also, you could also look at angle 4 and angle 1 also do the same thing. Okay, and all of these, again, linear pair, those are supplementary. Which means they add up to equal 180. Okay, well, if we go back to what we even tested on your test yesterday, you also notice that angle 2 is a vertical angle to 4. Okay, so now we have angle 2 and angle 4 are vertical angles. Okay, and remember, those are congruent. So those are going to be congruent or the same. Well, if you also notice too, we'll also have angle 3 and angle 1 are also vertical angles, which is also congruent. Okay, so now if you look down here at the bottom, you basically mimic or mirror, or basically the exact same thing as what you see right above it. Okay, since you see those are right above it, or they're basically the same, all the same rules apply as what we did from the intersection above, from the point above. Okay, so that being said, angle 6 and 5. I'll tell you what. Let's just say that all the linear. Let's just name all linear pairs with that. So we have 6 and angle 5, angle 5 and angle 7, angle 7 and angle 8, and then also the last one, angle 8 and angle 6. Those are all linear pairs. They're supplementary. You add them up, they equal 180. Okay, now to the vertical angles. You have angle 5 and angle 8, and you also have angle 6 and angle 7. Okay, well, because you have basically the exact same image from both of these two intersections. Okay, for example, if we have 5 and 8 are equal, okay, because of vertical angles, and then you can also take a look up and what does 5 represent in the one above? angle 2 is roughly the exact same thing as angle 5, just at a different location. Angle 4 is roughly the same angle as angle 8, just in the one above it. Okay? So it's one of those things we don't come to the conclusion that 2 is going to be the same as 4 because they're vertical angles, but they're also going to be the same as number 5. Okay, so 2 is going to be congruent to 5, and since 5 is congruent to 2, and 5 is congruent to 8, that means 8 and 2 are also going to be congruent. Okay? So that kind of helps out with the first question on letter A. The letter B, it says suppose a different transversal. Okay? So what you did, I should explain, is you have a set of parallel lines. This line right here is the transversal. Okay, you're going to be hearing that a lot. What's the transversal? That line is called the transversal. Is the line that intersects both lines. Okay, says suppose a different transversal intersects the parallel line. So maybe you have one that looks like this. Okay, that's still a transversal. Would you expect to find the same relationships with the measures of those angles? Okay, so what it's asking is if you had a different transversal, would your relationships from these angles, or basically from these angles, we expect something to be the same? Yeah, really. I mean, even like I said, even the transversal now, the angle measures themselves might be different. Okay, so for example, I mean, this could be 37, and this over here could be 41. Okay, now they're not congruent, but the relationships between this being 41 and this being 41 will be the same. Our angular relationships, whether it be vertical angles or linear pairs, will still be the same. Okay, so would you expect to find the same relationships? Yes, you would. And I'm going to pause this, write the explanation down, and then come back. Okay, because what I'm using is a recording device that only lets me to do something for 15 minutes for free. So chances are we're going to have 2 videos because I can't fit everything into 15 minutes. Okay, so I put yes, the measurements might be the same, but the relationships will. Excuse me. So the relationships will be the same as what we just talked about above, but just the actual physical measurements of those angles might not be the same. Okay, so I'm going to pause it, move down, and go to the first example. Okay, so identify the angle types. Identify each pairs of angles of each angle type made by the snowmobile trucks. Okay, so this is roughly about the same as what we did above. So hopefully you can pick out your linear pairs. In fact, you know what? I'm probably going to pause it, come back, and identify the linear pairs again. So I've identified all the linear pairs. So what I'll do is probably in this situation, since there's a lot to kind of maybe write down all the linear pairs, maybe pause this, or if something happens or you didn't understand something, you can always rewind, and things like that. So I listed all our linear pairs, okay? So now we'll talk about another type of relationship that we have here, okay? Another type of relationship that we have here, and this is called same side interior. Okay? Same side interiors are angles that are on the same side of the transversal, okay? And they are also on the interior, okay? So I'm gonna pause and then come back with a definition of that. So same side interiors are angles located on the same side of the transversal and inside the parallel lines. Okay, so a couple of examples of those would be angle 7 and angle 4. Okay, they are on the same side of the transversal, but yet inside the parallel lines. Okay, so another example of same side interiors would be 1 and 6, and we'll go into their relationship a little bit later. Okay, so the next thing that I kind of want to talk about is, or what we go over is what we call corresponding. Okay, Now, corresponding angles are roughly about what we talked about a little bit above, or what I talked about a little bit above, okay? Here, we were talking about how angle 2 was basically the exact same spot as angle 5 and have the same relationship, okay? Angle 2 is on this intersection is the top right. Angle 5 is also going to be on the top right, okay? So for that being said, corresponding, so also corresponding to 3 would be, well, corresponding, so if this is your middle, your bottom, if this is your middle here, your bottom right is angle 3. So we start in the middle here, your bottom right in this intersection is 7. So 3 and 7 are considered corresponding, okay? So it's kind of a definition of corresponding. Again, I'll write it and explain it. All right, so in this corresponding angles are angles that have the same location but at a different intersection, okay? So corresponding to 8, what's the same location but different intersections? See, here's your two intersections. So the same place but in a different location would be at angle 4, okay? So if I did angle 6, the corresponding would be angle 2. The corresponding to angle 5 would be angle 1, and then the corresponding to angle 7 would be angle 3. Okay, so that's going to be so those are your corresponding angles. Okay, so another one I want to talk about is alternate exteriors. Alternate exteriors are angles located on opposite sides of the transversal but outside the parallel lines. Okay, so for example, these will not be in effect because they're all inside of the parallel lines. Okay, so if I did angle 5, it's on the outside exterior. Okay, exterior means outside. So it's on the exterior, but it's on the opposite side of the transversal. So opposite sides of the transversal, but on the exterior is angle 3. Okay, so 5 and 3 would be considered alternate exteriors of each other. Angle 8 and angle 2 would be opposite or alternate exteriors of each other because on the opposite side of the transversal, and they are located on outside the parallel lines. So the next one I'm talking about is alternate interiors. Alternate interiors are angles located on opposite sides of the transversal, but inside the parallel lines. Okay, so we have our parallel lines, and so these won't be counted for because they are on the outside of the parallels. Okay, so we have our transversal. So if we have angle 6, its alternate exterior angle is going to be on the opposite side, but on the inside. That would be 4. Okay, so if I use angle 7, its opposite side, but also opposite side of the transversal, inside of the parallel would be angle 1. Okay, now all of these will be going into more in depth about the relationships. Just wanted to locate and briefly talk about them in this picture to kind of show you like an introductory beginning of this. Okay. So let's move on to the next page. We'll talk about some of these theorems and stuff. So same side interiors angles postulate is basically saying if you have two parallel lines and a transversal, same side interiors are supplementary. Okay, so in our example that we have, so we have our same side interiors. So if one of them is 120, the other one's going to be 60. If you add them up, that equals 180. Okay, angle 1 could be 100. And that makes angle 2 has to be 80. Okay, you could have angle 1 to be 75. If that's the case, that was going to be 105. Okay, those angles, they have to add up to equal 180. Okay, and that could be either those two, or if I labeled 3 and 4, angle 3 and angle 4, these two would also have to equal 180. Okay, so your same side interiors are supplementary. Okay, so yeah, supplementary. This concludes the end of this video. About my time's almost up, but I'm going to add another one, and yeah.